Have you ever seen a movie where someone carefully carries a small vial of a clear yellowish liquid? That, my friends, is very likely nitroglycerin. And let me tell you, it's one of the most fascinating and finicky substances on Earth. Nitroglycerin is a heavy, oily liquid that looks a bit like mineral oil or syrup. It's famous for being an incredibly powerful explosive, so powerful that just a tiny drop can cause a whole lot of trouble. It's not something you'd ever want to play with. Think of it as a tightly wound spring, just waiting for the tiniest nudge to release all its energy in one spectacular and very dangerous instant. So, what is this stuff made of? The ingredients are surprisingly simple, but the process is extremely delicate. Science. To make nitroglycerin, chemists start with glycerol. That's a thick, sweet-tasting liquid you might find in some soaps or even skin lotions. It's totally harmless on its own. But then, they very carefully mix that glycerol with two powerful acids, nitric acid and sulfuric acid. This process, called nitration, attaches nitro groups to the glycerol molecule. The final recipe creates the chemical compound C3H5N3O9, which is the scientific name for our explosive friend nitroglycerin. Now, why is nitroglycerin so incredibly unstable? It all comes down to its chemical structure. The molecule is packed to the brim with energy. Imagine trying to cram too many things into a very small suitcase. The latches are straining and ready to pop open at any moment. That's nitroglycerin. It has a very low activation energy, which is a sciencey way of saying it doesn't need much of a push to start a chemical reaction. A simple bump, a sudden jolt, or even a small change in temperature can be enough to set it off. It's like a house of cards built on a wobbly table. This extreme sensitivity is what makes pure nitroglycerin so hazardous to handle. In its liquid form, any little shockwave traveling through it can trigger a chain reaction. Dropping a container, shaking it too much, or exposing it to a spark could be all it takes to cause a massive explosion. The atoms within the molecule are held together by very weak bonds, and they are just itching to break apart and rearrange themselves into something much more stable. That desperate rush to become stable is what unleashes all of its incredible power. Consider this. Let's get down to the science of the explosion itself. It's truly amazing. Most things that burn, like wood or paper, need oxygen from the air around them to fuel the fire. This is called combustion. But nitroglycerin is special. It's a self-contained party in a bottle. The molecule C3H5N3O9 already contains all the oxygen it needs to explode, packed right alongside its fuel, carbon and hydrogen. This means it doesn't need any air to go boom. It can explode underwater, in a vacuum, or anywhere else because it brings its own oxygen supply to the reaction. When nitroglycerin is triggered by a shock or heat, its molecules begin to decompose or break apart at an incredible speed. This isn't a slow burn, it's a nearly instantaneous chain reaction. The weak bonds holding the molecule together snap, and the atoms rapidly rearrange themselves to form new, much more stable molecules. These new molecules are simple gases: nitrogen, carbon dioxide, water vapor, basically steam, and a little bit of oxygen. The key here is that these atoms are going from a cramped, unstable liquid state to a free, expansive, gaseous state. Here's where the power comes from. During the explosion, that small amount of oily liquid transforms into a massive cloud of super hot gas. How massive? The gases produced take up over 1,200 times the original volume of the liquid. Imagine one small can of soda suddenly expanding to fill an entire school bus. This happens in a fraction of a second, creating immense pressure. All that gas needs to go somewhere, and it pushes outward with incredible force, creating a powerful blast. It's this rapid, violent expansion that demolishes anything in its path. That violent expansion creates something else, a shock wave. This isn't just a strong gust of wind, it's a wall of compressed air that travels faster than the speed of sound. The shock wave is what you hear as the bang of the explosion, and it carries a tremendous amount of energy. It's the combination of the rapidly expanding hot gases and the powerful shock wave that makes nitroglycerin such a potent and destructive explosive. All of this from just a few shaky, unstable drops of liquid. Science is everywhere, and in this case, it's explosive. Every great scientific story has a beginning, and the story of nitroglycerin starts in 1847 with an Italian chemist named Ascanio Sobrero. He was the first person to create this powerful substance by carefully mixing glycerol with acids. However, his discovery was not a happy one. During one of his early experiments, a small amount of the chemical exploded, scarring his face for life. Sobrero was horrified by what he had created. He realized its immense destructive potential and publicly warned people against producing or using it, calling it far too dangerous and unpredictable to handle. Despite Sobrero's dire warnings, the sheer power of nitroglycerin was too tempting for others to ignore. Inventors and industrialists, including a young man named Alfred Nobel, saw its potential for blasting through rock in mining, construction, and engineering projects. People began producing it in larger quantities, but they quickly learned just how right Sobrero was. Early factories that made nitroglycerin had a terrible habit of exploding without warning, tragically taking the lives of many workers, including Alfred Nobel's own younger brother, Emile. The substance was a powerful tool, but it was a deadly one. Transporting nitroglycerin was a nightmare. Remember how sensitive it is to shocks? Now imagine trying to move it in large quantities over bumpy, unpaved roads in a horse-drawn wagon or on a rocking ship. It was a recipe for disaster. People tried packing the liquid-filled containers in crates with sawdust or other materials to cushion them, but these methods often failed. Shipments would frequently explode in transit, destroying docks, railway stations, and even entire city blocks. In one famous incident, a crate of nitroglycerin exploded in San Francisco, leading to a citywide ban on its transportation. The problem was so bad that people started calling nitroglycerin blasting oil, and it earned a fearsome reputation. Many countries outlawed its transportation altogether, making it nearly impossible to get the explosive to the mines and construction sites where it was needed most. The world had a powerful new tool, but it was so dangerous that it was almost useless. Someone needed to find a way to make nitroglycerin stable enough to handle and transport safely. The challenge was to tame this explosive beast without taking away its incredible power. A solution was just around the corner. The person who finally solved this explosive puzzle was none other than Alfred Nobel. Haunted by the dangers of nitroglycerin, especially after the factory explosion that killed his brother, Nobel dedicated himself to making it safer. He spent years experimenting, trying to find a way to stabilize the liquid without reducing its explosive force. He tried mixing it with all sorts of materials like charcoal and brick dust, but nothing quite worked. The goal was to turn the volatile liquid into something more like a solid, which would be far less sensitive to accidental shocks and bumps. The breakthrough came somewhat by accident. Nobel was transporting cans of nitroglycerin packed in a type of absorbent fossil-rich clay called kieselguhr, pronounced kieselguhr. He noticed that one of the cans had leaked, but instead of creating a dangerous puddle, the kieselguhr had soaked up the liquid like a sponge. This gave him a brilliant idea. He began methodically experimenting with mixing nitroglycerin with kieselguhr in precise proportions. He discovered that a mixture of 3 parts nitroglycerin to 1 part kieselguhr created a pliable, dough-like paste. It was a whole new substance. This new material was a game changer. It was powerful, but it was also remarkably stable. You could drop it, shake it, and even light it with a match, and it wouldn't explode. It needed a much stronger shock to detonate, which could be reliably provided by a blasting cap, another one of Nobel's inventions. He had successfully tamed the beast. He named his new creation dynamite after the Greek word dynamis, which means power. Dynamite was the perfect solution, all the power of nitroglycerin in a safe, manageable, and transportable form. The invention of dynamite in 1867 completely revolutionized construction, mining, and engineering. Suddenly it was possible to blast tunnels through mountains, clear canals, and build foundations with a level of safety and control that was previously unimaginable. Alfred Nobel became incredibly wealthy from his invention, but he remained conflicted about its use in warfare. He ultimately used his vast fortune to establish the Nobel Prizes, rewarding advancements in science, literature, and peace. It all started with a slippery, dangerous liquid and one scientist's quest to make it safe for humanity. Consider that.